Hello, Algebra 1 CP students. This is a lesson for March 26th for my B-Day students and March 27th for my A-Day students. In this lesson, we're going to review classifying polynomials, just go over that terminology again, because it's going to come up over and over again. And last time we talked about adding and subtracting polynomials. Today we're going to start talking about multiplying polynomials, which is a tricky subject. So we're going to start by multiplying monomials, and then I'm going to show you how to multiply monomials by polynomials. The good news, it uses a lot of skills you already have. All right, so let's review classifying polynomials. If you remember, a polynomial is a sum or difference of one or more monomials. So this is an example of a polynomial. 6x squared is a term, 5x, and then 11, and then they're all being added. A degree of a polynomial is a power of the highest degree monomial. So a degree of this polynomial is going to be second degree, because that's the highest power. Leading coefficient is the real number multiplying the variable part of highest degree monomial. So the coefficients here are 6, 5, and 11, but 6 multiplies the x squared term, so 6 is the leading coefficient. And then we said there's a few nicknames for different types of degrees. So if something is degree 0, it's called a constant or constant term. A first degree, so just x, is called a linear term. A second degree, or x squared, is called a quadratic term. A third degree, or x to the third, is called a cubic term. A fourth degree, x to the fourth, is called a quartic term. And a fifth degree, x to the fifth, is called a quintic term. I would say the biggest mix-up here is between second degree and fourth degree, because the word quad kind of looks like the root for 4, and it really is the root for 4, but what they mean by this is it's a square, like quad as in square, and because when something is raised to a second power, we say it's squared. So this QUA comes from the word square, and in here quartic, this QUA comes from the word quart or 4. Okay, so there's some mix-up sometimes with between second degree and fourth degree. Quadratic is second degree. And then commonly used nicknames of different number of terms. If a polynomial has one term, we call it a monomial, mono meaning one. Polynomial has two terms, we'll call it a binomial, bi meaning two. And then if a polynomial consists of three terms, we'll call it a trinomial, trinomial meaning 3. All right, so for problem 1, this is going to be a review, just like we do in class. We often review previous material. For each polynomial, state its degree, the number of terms, and leading coefficient, and then name the polynomial. So problem 1, part A, it says x to the fourth minus 8x cubed. This is a polynomial. All right, the degree of this polynomial is 4, or fourth degree, because the highest power is 4. The number of terms is 2. X to the fourth is one term. Negative 8x cubed is the other term. And the leading coefficient is the number multiplying x to the fourth, which in this case is 1. All right, now we're going to come up with a full name for this polynomial. The first part of the name is the degree. The second part of the name is the number of terms. And then if you can use a nickname do. So a fourth degree nickname is quartic. If something has two terms or is made up of two parts, we call it a binomial. So this would be a quartic binomial. Quartic because it's fourth degree, binomial because number of terms is 2. All right, problem 1, part B. 3x squared plus 6x minus 9. The degree is 2 because the highest power on the variable part is 2. The number of terms is 3. 3x squared is the first term, 6x is the second term, negative 9 is the third term. And the leading coefficient is 3. So now we're going to come up with a full name. Full name comes from the degree plus number of terms. Second degree things are called quadratic. Number of terms 3, so it's a trinomial. Quadratic trinomial. You're going to see a lot of quadratic trinomials, okay? It's kind of like in 6th grade, you spend a lot of time multiplying 2-digit numbers by 2-digit numbers. We're going to spend a lot of time working with quadratic trinomials just because they're complex enough that you can see some of the properties of polynomials, but they're not so complex that you get overwhelmed by detail. But you'll see this set up quite a bit. And then the last part C, problem 1 part C, 1/2 x cubed plus 2/3 x squared minus 1/5 x. The degree is 3 because that's the highest power on the variable part. The number of terms is 3. 1/2 x cubed is the first term, 2/3 x squared is the second term, and negative 1/5 x is the third term. And the leading coefficient is 1/2. So the full name, a third degree polynomials we call cubic. If there's 3 terms, we'll call them trinomial. So it's a cubic trinomial. All right. Last time we talked about adding and subtracting 2 monomials. We said we have to make sure they're like terms or the variable part is exactly the same. Then you add or subtract the coefficients and keep the variable part. So 2x plus 2x plus 2x equals 6x, not 6x squared, right? Or 6x cubed. Because when you add things, what changes is how many there are of them, not what they are. All right, when you multiply 2 monomials, and we know this from studying properties of exponents, you multiply the coefficients and then you multiply the variable parts. So 2x times 2x times 2x, 2 times 2 times 2 is 8, x times x is x cubed. And of course, when you multiply things, you just stick them together. You don't have to make sure that they are like terms first at all. So multiplication is kind of easier in this respect. All right, so problem 2, I'm going to ask you to multiply monomials. And this might look familiar. We've seen problems like this when we studied properties of exponents. So it's pretty much a similar problem to the one we've done before, but just in slightly different context. So 3x squared times 6x times negative x squared times negative 10x. So I have 4 monomials. I'm going to multiply them. The first thing I'm going to do is rewrite the problem. 3x squared times 6x times negative x squared times negative 10x. You don't have to do this, but I'm going to rearrange the terms so that the coefficients or the constant terms are together and the variable parts are together. So 3 times 6 times negative 1, because negative x squared means negative 1 times x squared. So negative 1 times negative 10, and then times x squared times x squared times x. And remember, I can do this because multiplication is both commutative and associative. All right, multiply the coefficients. Let's do the easy part, multiplying numbers, integers. 3 times 6 is 18, times negative 1 is negative 18, times negative 10 is 180. And then I still have my variable parts. All right, in order to multiply my variable parts, I'm going to apply Rule 5. Rule 5 says, if you're multiplying terms with the same base, you keep the base and add the exponents. In this case, the base is x, x, and then the exponents are 2. X by itself has an exponent of 1, 2, and then 1. So I get 180 times x raised to 2 plus 1 is 3, plus 2 is 5, plus 1 is 6, times x raised to the 6th. And then the last step I'm going to simplify. I'm just going to rewrite that as one term, 180 x to the 6th. So you multiplied 4 monomials to get 1 monomial. It's very similar to the way we multiply 4 numbers to get 1 number, okay? Polynomials actually have a lot of properties that numbers do, because a number is a 0th degree polynomial, so they belong to that family. So 3x squared times 6x times negative x squared times negative 10x equals 180 x to the 6th. All right.